For those of you that haven't read the description of this video, a couple of words of caution. None of the radio control equipment featured in this video has been specifically sold or made for live steam or other garden railway projects. I do not represent any hobby sales outlet. The information in this video has been provided in good faith as one enthusiast to another. So many people would have started out with a 27 megahertz transmitter. This is one of the later ones, the ACOM's Techni Plus. These have an aerial which you need to extend. It's some 3 feet long. This one has a power switch, and you've got 3 lights here. Green means that the batteries are good, orange means times to change the batteries or recharge them, and red means don't use. This one is one of the land 2-channel models, so the channel on this side would just operate left and right, and the channel on this side would operate up and down. 27 megahertz originally, when it came out, only had 6 channels, and these were controlled by crystals. Each transmitter had to have the specific crystal, and the corresponding receiver crystal had to be fitted as well. This was further improved by splitting the channels, so eventually there were 12. This model has basic potentiometer trims on the channels, and there is also the facility to reverse the channels on here. And the disadvantage of this type of transmitter is that it has 8 AA batteries or rechargeables. From 27 megahertz, the systems then moved on to 35 megahertz for the airborne models and 40 megahertz for the land models. I don't have a 40 megahertz transmitter, but they're very similar to this. This is a 35 megahertz transmitter. Again, it's got a long aerial that has to be fully extended. This one has now got a partial LED display. This one shows the voltage and does a few little bits and pieces. This is a 5-channel one, so as well as fore and aft and left and right on both the sticks, it has a switch for the 5th channel. And like most transmitters of this time, you could replace the dry cells or the rechargeable cell batteries by putting in a battery pack. This is a 9.6 volt battery pack. The big problem with 27 megahertz was that it suffers quite badly from interference. Even here in my kitchen, I do get glitches using 27 megahertz, probably due to some of the electrical equipment that I have in here. From the 35 and 40 megahertz, the next system that came in was the 2.4 gigahertz. And this is a Spectrum DX6i. Again, this has got an LCD display on it. This one's got lots of functions, menus, etc. You can put in 10 different models in here to have all the various models in one transmitter. 6 channels, so we've got the fore and aft, left and right on the 2 sticks. And then on top of that we have a flap switch here, and on the top we have the gear switch. This one has a split aerial, and this is a great advantage. These days, where everybody's used to using an infrared remote control for the various home entertainment systems, they're used to pointing the handheld controller direct at the item they want to control. In radio control, the worst thing you can do is actually have the aerial pointing direct at your model. So with this particular transmitter you can actually rotate the aerial, and so that the signal strength will be the best if you're actually pointing the transmitter at the model you're controlling, but the aerial is at 90 degrees here. Another big advantage of most of the 2.4s is they've reduced the power requirement, so we've now gone down to 4 AA cells, which is a big advantage. So looking for a much smaller and lighter transmitter, I considered using one of these. This is a 5-channel DSM2, which is the type of modulation used for 2.4 gigs on this one. And this was made for a particular brand of combat helicopter called the Force RC. This is 5 channels, so as well as the 4 channels on the sticks here, this one has the novel addition of a 5th channel, which is the red switches here. And as you will hear, it gives you a machine gun noise. This was when you were combating your opponent helicopter or blowing up a ground target. These transmitters can still be picked up as this range has been discontinued, although it's a little bit more a coincidence that when I discussed this on an online forum, the eBay trader put up the price of this transmitter quite significantly, and it put it outside of my budget range. Let's quickly discuss the advantages of using the 2.4 GHz systems. You can see here externally on the transmitter it's got a very small aerial. Similarly, the receivers have small aerials as well, as we shall see later. It's powered by 4 AA batteries, so it's reduced the requirement to have 8 cells. But the big advantage is that these transmitters do not use any crystals. So there's no crystals required for the transmitter or the receivers, as there is in 27, 35 and 40 megahertz. So there's no disadvantage of having to wait for your crystal or channel to be vacated so that you can use your transmitter, and therefore there's no requirement to have a frequency control board at a large event like an indoor garden railway exhibition. What 2.4 GHz systems do use is they use a modulation, and the modulation used varies between the different manufacturers. The systems I'm showing you here in this video is the Spectrum system, and they use DSM, DSM2 and DSM-X as a modulation. So if you have that type of transmitter, you need to ensure that the receiver that you use is also of the same modulation as well. And so I found another alternative and cheaper transmitter. These are all badged as different models. This is the Blade model. The transmitter is an MLP4 DSM, and this one is 4 channels. As you can see, it's a nice small size, almost like a games console. And the big advantage in these ones is, compared to the old 27 megahertz, is that this one again is 4 AA cells. So whereas the original 27 megahertz transmitter weighs in at some 650 milligrams, this transmitter, including the batteries, only weighs 300 milligrams, so it's just slightly less than half the weight of the 27 megahertz transmitter. So let's have a look at the functions of this transmitter. So we have a power switch here. Switch on, you get a couple of beeps, and then you can see we have a steady red LED. This is not actually indicating the power, but it's actually indicating that the transmitter is in the full rate mode. This transmitter has the facility for dual rates. If I push down the right stick, there's a little switch you can hear there. If I let it go, you can now see that the LED is flashing, and this means it's gone in to the rate which is recommended for beginners. So that reduces the control in all of the channels, including the throttle. And to revert back to full mode, push down the switch, push down the control, and we're back into the full rate mode again. When you buy these transmitters, they come with no instruction manual. You have to refer to the various airplane and helicopter models that these transmitters were designed for to get the instructions. And again, like some things, there are actually a couple of features which have not been documented, but with the wealth of forums available online, you find out some. And this was one I found out recently. This shows you what happens when you have low battery voltage. So this is telling you to switch the transmitter off and change the batteries. So a couple of features that this transmitter has as well. I've got the control on this tram on the elevator control here. I can use these to adjust the trim. So that allows you to put some fine adjustment into the servo if you can't take that out on the control rod. So this transmitter has servo reverse on 3 of the channels: the elevator, the airlong and the rudder channel. Unfortunately it doesn't do it in the throttle channel. So let's look at reversing this channel here. So at the minute, the elevator, if I go elevator forward, the servo is moving to the right. Elevator back, the servo is moving to the left. So to reverse the servo, I need to hold this button down here, which is the lower trim button for the elevator channel. Switch the transmitter on and hold it until we hear a noise. That's now set it to the opposite direction. So this time if I go elevator forward, servo goes to left, elevator back, servo goes to right. So I've reversed the channel. As I say, unfortunately, this channel here, which is the normal throttle channel, there is no servo reverse in that, which, as we'll see in a minute, is a bit awkward for this particular Cheddar model. Let's have a look at the receiver side of this radio control equipment. What we require is a receiver. This model is the Orange RX R615 receiver, which is equipped with 2 aerials. The previous model had the facility for putting in a satellite receiver, as it only had 1 aerial. These aerials should be mounted at 90 degrees for the best reception, and so what I've done here is I've actually sheathed the aerial with some black cable sheathing so that it holds the shape at 90 degrees. This model is 6 channels. There's the pins you can see here, and it's supplied with a bind plug as well. And this would be loose, and this would go in the bind port, which is the bottom port here, which we will see further on in this video, how to use that. We need a battery pack, and for this one I'm just using the standard 4x AA cell pack, and this one is fitted with the BEC plug or the JST plug, which will just plug straight into the receiver. One thing that I recently discovered is you can use one of these devices. These are actually designed for the LiPo batteries, and this model is actually for the 1 to 8 cell battery. What this one does is it gives you a visual indication of the voltages, the total voltage, and also the individual voltage of the cells, which is more important on the LiPos. And it's got audio alarms here when the voltage gets too low. But having bought one of these for some ridiculously cheap price from Hong Kong, I found that you can actually use this to check the voltage on your battery pack here. Putting the black negative wire to the bottom pin, plugging it in. The display will then come up, and you can see here it's telling us that all is 5.49 volts, and in this case it's only indicating one cell, which is also 5.49 as well. So that is telling me that I've got a good voltage on this receiver pack. There's no requirement to use a separate on-off switch, and many of the on-off switches are of quite a cheap design and tend to fail. On this particular model you can just plug the battery straight in. And there we are, we have applied power direct to the receiver. The flashing light means it's gone into bind mode, which I'll explain later on in the video. So here is how we bind the orange RX receiver to this transmitter. The receiver here, we've got the bind plug in the lower one here, which is the battery bind port. Plug in the battery to any other channel, and the black negative goes to the bottom pin. You can see the light is flashing, which is telling me that the receiver is in bind mode. We now go to our transmitter, hold the left stick down, you hear it click, then switch the power on, release the left stick, and the transmitter has now gone into bind mode with a beeping. And now we've got a steady LED on the transmitter, a steady LED on the receiver. And if I move the throttle control, you can see that I'm operating the regulator reverser valve on this model. To complete the binding process, we now need to remove the bind plug from the receiver. And so that receiver is now bound to this transmitter. Okay, so that gives us a bit of a problem where normally you would bind with the throttle in the lower position. That's because this transmitter is designed for operating an airplane or a helicopter, so you don't want a power applied to the rotors or to the propeller when you first switch it on. However, here on the Cheddar tram you can see that the servo has gone to full deflection one way. In this case it's actually with the regulator fully open. Not an ideal position for starting off an oscillating live steam locomotive. So for this particular model I can actually bind the transmitter and receiver in a slightly different mode, and we'll look at that in a minute. This time to set up this transmitter properly for this tram, what I'm going to do is I'm going to bind it with the throttle control in the middle position. So in the middle position, pushing the stick down, power on, release the stick, it goes into bind mode. It's now bound, and if you now look at the tram, you will see that the regulator control is now in the middle. Another feature that's not documented, and I only picked up in the online forums, is that these receivers have a fail-safe, and that's quite easy to show. It will fail-safe to the bound position. So in this case I've got the throttle fully down, which means that the regulator is fully open. If I now simulate a signal failure by switching the power switch off here, you see the light's gone off on the receiver, the servo has gone back into the mid position, and there is a red LED which has got a flash. The single flash means that it has lost the signal once. If I switch the power back on again, it's now bound again, and the regulator control has gone back to the position where the throttle control was on the transmitter. Switch the power off again. It goes to the default position, which is regulator in the neutral position, and this time you can see it's flashing to red, telling you that it's lost the signal twice. So that's nice to know, that if the receiver loses the signal for any reason, then this tram is going to come to halt, as opposed to running away if it was on 27 megahertz.